Okay, next we're going to solve each of these compound inequalities. So we also have to write it in interval notation and also graph it. So the first one would start by subtracting r on both sides and adding 7. So this means now we have 2r is less than or equal to 14, and then dividing by 2, we get that r is less than or equal to 7. The word in the middle here is and on the right inequality, we're going to subtract 6r and subtract 7. So now we have 5r is greater than negative 10. And then divide by 5, we get that r is greater than negative 2. Now if we're thinking about this answer, right, the numbers that are bigger than negative 2 and less than or equal to 7, these would be the numbers that are from negative 2 up to and including 7. So between negative 2 and 7. So on a number line, that would be an open circle on negative 2, a closed circle on 7, and then we would graph and plot all of the numbers in between, which are a part of the solution. Okay, next let's go ahead and do part D. So on part D again, I'm going to start by solving the inequality on the left. So that gives me 4 plus 8n is less than negative 12. Subtract 4 on both sides, get 8n is less than negative 16. Divide by 8, we get n is less than negative 2. The word in the middle here is or. And then for the inequality on the right, start by subtracting 19. And 46 minus 19 is 27. So we get 9n is greater than 27. And then divide by 9. 27 divided by 9 is 3. So we get n is greater than 3. Since we are looking for numbers that are less than negative 2 or greater than 3, those are two separate inequalities. So we're going to have from negative infinity up to, but not including negative 2. All of those numbers are a solution, or the other part of the solution is from 3, not including 3, all the way to infinity. So if I were to graph that on a number line, this would be open circle on negative 2 and shading all of the numbers that are less than that. Or another part of the solution is open circle on 3, and then all the numbers to the right of 3 are a part of the solution as well. All right, let's move on to part B. So for the inequality on the left, we can start by adding 15n and adding 2. This gives us 3n is less than or equal to negative 12. And then divide 3 on both sides, n is less than or equal to negative 4. The word in the middle here is and. Then on the inequality on the right, subtract n on both sides, subtract 9. We get that n has to be less than or equal to negative 7. So if we're thinking about the numbers that are both less than negative 7 and less than negative 4, those would be the numbers that are less than or equal to negative 7. Because all of the numbers that are less than or equal to negative 7 are included in less than or equal to 4, but not all of the numbers that are less than or equal to negative 4 are included to less than or equal to negative 7. So the solution here is just negative infinity to negative 7, close bracket on negative 7, since negative 7 is included. Okay. Next, let's do part E. So I'm going to start by subtracting 7 on both sides. So we get negative 20v is greater than or equal to 60. And then we have to divide by a negative. When we divide by a negative, it does switch the inequality symbol. So that gives me v is less than or equal to -3. The word in the middle here is or. And then on the inequality on the right, I start by subtracting 9, which -95 minus 9 is -104. So I get 8v is greater than or equal to -104. And then -104 divided by 8 gives me -13. So I get v is greater than or equal to -13. Now if we think about those numbers, right, which numbers are going to be more than -13 or less than -3, that would be all numbers, right? If we're thinking about like on any number that we could think of, -14 or even 0 or -6 or 30, any number would fit into one of these two categories. So this is actually all real numbers. I would shade the entire number line because every single number would either be less than or equal to -3 or greater than or equal to -13. So this is all real numbers, which in interval notation would be -∞ to +∞. All right, let's do part C. So on part C, I can start with distributing -2. We have -12 plus 14x is less than 16 plus 7x. We can subtract 7x on both sides and add 12. So we get 7x is less than 28. And then divide by 7. 28 divided by 7 is 4. So we have x is less than 4. The word in the middle here is and. On the inequality on the right, we can start by subtracting 12x and subtracting 7. So we get 1x is, which I can write it just here at the bottom, is greater than or equal to 6. So if we're thinking about the numbers that are both less than 4 and also more than or equal to 6, well, there are no numbers that are both less than 4 and also more than or equal to 6. So this is actually no solution. Okay, and then the last one, part F. Starting on the inequality on the left, we can subtract 4. So we get -9r is less than 9. Then dividing by a negative is going to flip the inequality. So we get r is greater than -1. The word in the middle is or. And then I can, on the inequality on the right, add 4 on both sides. We get 3r is greater than or equal to -6. Divide by 3. R is greater than or equal to -2. So, which numbers are going to be more than -2 or more than -1? Well, the numbers that are more than or equal to -2 are also more than -1. So I can just say that this is the numbers that are greater than or equal to -2. So the solution would be -2 to infinity. Okay. All right, number 13, we're solving each of these absolute value equations. So to solve the absolute value equation, I have to isolate the absolute value first. So I'm going to start by adding 7. So now I have -9 times the absolute value of 8 plus 6x is equal to -25 plus 7, which is -18. And then I want to go ahead and divide by -9 so that I can get the absolute value completely by itself. So now the absolute value 8 plus 6x is equal to 2. So distance, this absolute value is going to equal to 2 in two places. Because what's inside of the absolute value can equal positive 2, or if what's inside of the absolute value, it can equal negative 2 as well. Because since I'm taking the absolute value, when I take the absolute value of a negative 2, it's going to make it a positive 2. So the absolute value here, if what I have on the inside is negative 2, the absolute value of negative 2 will be 2. So I'm going to get two solutions here. Subtract 8, we get 6x is equal to negative 6, and then divide by 6, we get x equals negative 1 is one of my answers. And then on this side, subtract 8, 6x equals negative 10, divide by 6, x equals negative 10 over 6, which would simplify to 5 over 3. And those are my two solutions. Next, let's do part B. So on part B, the absolute value is already isolated. So what's inside of the absolute value can equal the positive 5x plus 8, or it can also equal negative 5x plus 8, which would change the sign of both the 5x and the 8. So I have my two equations to solve. So on the one on the left, and subtract x on both sides, and subtract 8. So I get negative 4 is equal to 4x. Divide by 4, x equals negative 1. On the one on the right, I can add 5x on both sides, and subtract 4. So I get 6x is equal to negative 12. Divide by 6, x equals negative 2. Now, when we have our distance equal to an expression like this, we need to kind of check and make sure that the solution actually works out. You only have to do this when it's equal to an expression. So the question is the absolute value of negative 1 plus 4 equal to 5 times negative 1 plus 8? Well, negative 1 plus 4 will be 3. The absolute value of 3 is 3. And 5 times negative 1 is negative 5, plus 8 is 3. So this works out. Yes, negative 1 is a solution. Now, just because negative 1 is a solution doesn't mean that negative 2 is a solution. So we need to go ahead and check negative 2 as well. So I'm going to plug it into the equation. Is the absolute value of negative 2 plus 4 equal to 5 times negative 2 plus 8? So on the one on the left, negative 2 plus 4 will be 2. The absolute value of 2 is 2. And then on the right, 5 times negative 2 would be negative 10. Negative 10 plus 8 would be negative 2. So is negative 2 equal to a positive 2? No. So this a solution is an extraneous solution. We would remove that solution. So there's only one solution on part B. X is negative 1. Okay. Part C. I'm going to start by isolating the absolute value. So I'm going to subtract 5 on both sides first. So I get negative 36 is equal to 9 times the absolute value of 5p minus 4. Then I need to divide by 9. So we get the absolute value is equal to negative 4. Now, here's the problem with this. The absolute value cannot equal a negative, because remember, the absolute value is distance, and distance is always positive. No matter what number I have inside of here, when I do the absolute value, it's going to be a positive. So this is not possible for it to equal a negative. So this is no solution. All right, let's move on to part E. On part E, I will add 5 first. So I have negative 10 equal to times the absolute value of 5 and plus 6 equal to 0. And then I will divide negative 10 so I could get the absolute value completely by itself. So now I have the absolute value of 5n plus 6 equals 0. Now, the distance, right, no matter what I get inside of here, this would have to be on the inside of 0 in order for it, when I take the absolute value, to equal 0. So what's inside of that absolute value, 5n plus 6, has to equal 0. And positive 0 and negative 0 is no difference. So this is just going to give us one solution. Subtract 6, divide by 5, n equals negative 6 over 5. Next up, part B. I'll start by getting the absolute value by itself by subtracting 1. So now I have 3 times the absolute value. Negative 10 plus 5p equals 105. And then dividing the coefficient there of 3. 105 divided by 3 is 35. So now that I have the absolute value isolated, I can now determine, well, what's on the inside here would have to equal either a positive 35 or a negative 35. Because if what's on the inside here is a positive 35, then absolute value of 35 equals 35. Good, that would be a solution. Or if what's on the inside of there is a negative 35, that's okay as well because it's the absolute value. So it will, the absolute value of negative 35 will equal positive 35. So that gives me my two equations. So now I just have to solve those two equations separately and I will get to two solutions. So I'll start by adding 10. So I have 5p equals 45, and then 45 divided by 5 gives me my first solution, which is 9. And then on this side, add 10 on both sides. I get 5p equals negative 25, and then divide by 5 gives me my second solution, which is negative 5. All right, last example, part F. So here I have the absolute value already isolated. So I'm going to go ahead and set that equal to the positive 4x plus 6 and the negative 4x minus 6. On the left side, I can subtract 4x and subtract 14. So now we get 2x is equal to negative 8, and then divide by 2, x equals negative 4. And then on the one on the right, add 4x on both sides, subtract 14. We get 10x is equal to negative 20, and then divide by 10, x equals negative 2. So I have what seems like two solutions, but remember when it's equal to an expression, you do have to check them. So let's go ahead and check negative 4. So 4 times negative 4 plus 6, does that equal absolute value of 14 plus 6 times negative 4? Well, 6 times negative 4 is negative 24. Negative 24 plus 14 is negative 10. Absolute value of negative 10 is positive 10. On the left side, 4 times negative 4 would be negative 16. Negative 16 plus 6 would be negative 10. So those are not the same. So negative 4 is extraneous. Let's check negative 2. So again, plugging into our equation, 4 times that negative 2 plus 6, does that equal the absolute value of 14 plus 6 times negative 2? So 14, 6 times negative 2 is negative 12. Negative 12 plus 14 is 2. Absolute value of 2 is 2. On the one on the left, 4 times negative 2 is negative 8, plus 6 is negative 2. So actually that doesn't work either. So both of our solutions that we got are actually extraneous, which means we're left with no solution. Okay. Last one, number 14. Okay, we're going to go ahead and solve these inequalities. On the one on the left, I have to go ahead and isolate the absolute value first. So I'm going to go ahead and subtract by 5 over 2. which I need a common denominator for, so I'll have to multiply this one by 2 and multiply this one by 3. So that'll be 16 minus 15, which is 1. And then on the left, we have 3 over 2 times the absolute value of 1 plus 1/3 x. And I can get rid of 3 over 2 by multiplying by 2/3. So now I have the absolute value isolated. 1 plus 1/3 x is greater than or equal to 2 over 18, which would be 1/9. And then now the absolute value is by itself, so we're going to go ahead and split it up into 2 separate inequalities. Now, the absolute value is going to be bigger on the outsides. So this is going to be 1 plus 1/3 x is greater than or equal to 1/9, or 1 plus 1/3 x is less than or equal to negative 1/9. Subtract 1 on both sides. 1/3 x is less than or equal to negative 10 over 9. And then multiply by 3. X is less than or equal to negative 10 over 3. Over here, subtract 1 on both sides. We get 1/3 x is greater than or equal to negative 8 over 9. And then multiply by 3. We get x is greater than or equal to negative 8 over 3. So that's our solution. X has to be greater than negative 8 over 3 or less than negative 10 over 3. Part F, again, we're going to start by isolating the absolute value. So subtract 2 on both sides. Then multiply by 2/3. So now we have the absolute value is greater than or equal to negative 2/3. Now, the distance, the absolute value, is going to be greater than or equal to, but any number that I will put in here is going to fall into being greater than or equal to the negative 2/3. Because no matter what number I put in here, right, when I take the absolute value, it's going to end up being a positive. And a positive will always be greater than or equal to that negative. So this is actually all real numbers. All right, let's move on to part B. So on part B, I'm going to go ahead and subtract 36 first to get the absolute value by itself. So now I have absolute value is less than 0. And the absolute value cannot be less than 0. Again, no matter what I put in here, when I take the absolute value, it's going to be a positive number or it'll be 0. So it cannot be less than 0. This would never be able to happen, so this is actually no solution. Okay, let's do part G. So on part G, I'm going to go ahead and subtract 6 on both sides. So I have 0 is greater than or equal to the absolute value of 2x minus 9. And I find it to be a little bit easier to read or think about, the numbers if you put your absolute value on the left. Because remember, your variable really needs to be on the left in order to read the inequality properly. So this distance, no matter what I get here, is going to be less than or equal to 0. And if we think about that, it cannot be less than 0. No matter what I put in here, it's going to either be 0 or a positive number, more than 0. So the less than 0 part can't happen, but the equal to 0 part can happen. So the only thing that would make this equation, this inequality true, would be that what's inside of the absolute value, the 2x minus 9, is actually equal to 0, which would mean that the only solution would be that x is specifically 9 over 2. So there's just one solution. All right, let's do part C. Again, I find it easier to read when the variable is on the left, because if not, then you just have to invert the inequality symbol in your mind. So we're looking for a number that, when I take the absolute value, is going to be more than 0. Well, that's going to be all numbers, right? All numbers are going to be more than 0, except the one that makes it 0. Because if 3x plus 9 is equal to 0, then that would not meet the criteria, because 0 greater than 0 would not make that statement true, and will be the only case that is a number that would not be a solution. All other numbers will be a solution. So this is going to be all real numbers, with the exception that x not be negative 9 over 3, which would be negative 3. So it's going to be all real numbers, but x not being negative 3. Any other number, x could be negative 3.5. X could be 30, negative 327. It could be any number, just not negative 3. Okay, part H. I'm going to go ahead and subtract 10 first. So now we have 6 is greater than 6 times the absolute value of x plus 7, excuse me, 8x plus 7. And then I'm going to divide by 6. And I'm also going to go ahead and flip this around. So the absolute value of 8x plus 7 is less than, and then 6 divided by 6, which is 1. So the distance is smaller than 1, well, as long as the whatever's inside of this absolute value is less than 1 and it's bigger than negative 1. Because all of those numbers in between negative 1 and 1 will have a distance of smaller than 1. So this would be that x is less than, if we subtract 7, that would be negative 6 over 8, which simplifies to negative 3 over 4. And subtract 7, that would be negative 8, divided by 8 would be negative 1. X is greater than negative 1. So those would be, it would have to be between those two numbers, and that would be a distance of less than 1. Okay, let's do part D next. So on part D, I'm going to subtract 9 first. So now I have 4 times the absolute value of 8n minus 2, less than or equal to 40, and then divide by 4. So absolute value of 8n minus 2 is less than or equal to 10. So where is the distance smaller than 10? Well, the distance is smaller than 10 in between negative 10 and positive 10. So it has to be less than or equal to 10 and greater than or equal to negative 10. So solving this one on the left, we would add 2, divide by 8, which is 12 over 8, which simplifies to 6 over 4. Just kidding. 12 over 8 would simplify to 3 over 2. So n has to be less than or equal to 3 over 2. And add 2, negative 8 divided by 8, negative 1. N has to be greater than or equal to negative 1. Okay, part I. Start by subtracting 14 on both sides. we get negative 5 times the absolute value of x minus 7 is less than 25. Then divide by negative 5. The absolute value of x minus 7 is less than, well, actually we're dividing by a negative, so that would flip that sign. So it's now changing it to a greater than negative 5. All right, so what numbers for x would fit this inequality? Well, whatever x is, when we take the absolute value, this will either be 0 or a positive number. And 0 or a positive number is always going to be more than negative 5. So this is all real numbers. All right, part E. Start by subtracting 5. And then negative 108 divided by negative 3 is going to be positive 36. So where is the distance going to be less than 36? Well, in between 36 and more than or equal to negative 36. So we have 9p plus 9, which we would solve by subtracting 9 first. So we get 9p is less than or equal to 27. And then divide by 9, we get p is less than or equal to 3. And subtract 9 on this side, we get 9p is greater than or equal to negative 45. Divide by 9, p is greater than or equal to negative 5. So it would have to be, p would have to be between negative 5 and 3. All right, last question. Subtract 3 on both sides. 6 times the absolute value, negative 4x plus 79 is greater than 66. Divide by 6. We get the absolute value of negative 4x plus 79 has to be greater than 11. Now, where is the distance more than 11? Well, on the outsides of 11 and negative 11. So it would have to be more than 11 or less than negative 11. So to solve the one on the left, I'm going to start by subtracting 79. So we get negative 4x is greater than negative 68. And then negative 68 divided by negative 4 will give me 17. Then for the one on the right, subtract 79 on both sides. We get negative 4x is less than negative 90. And then divide by negative 4. X is less than, it would be 90 over 4, which would simplify to 45 over 2. Oop. And since I divided both sides by a negative, it does flip both of these inequalities around. So it's actually x is less than 17 and or x is greater than the 45 over 2.